Can I start now? Hey, everyone. Yeah, this is the session about coding practices. How many of the audience are developers? Give me a wave. Cool, nice, nice. Yeah, if you are not a developer, you should bring your developers here or pass on this session. So I'm going to talk about some battle-tested coding practices that you should use when you code for EVM. And I've seen disasters because people miss some of those. OK, although the title says in relation to establishing a DAO, this one has nothing to do with DAOs. Believe it or not, when you write smart contracts, people are going to send tokens to your smart contracts. And if you don't handle it, essentially they burn their tokens. This includes ETH, USDC, or any tokens they send. So make sure you handle that. Right? Which means in your smart contract, have those functions. Receive for ETH, token received for ERC 223, on ERC 721 received for NFTs. Unfortunately, there's no catch-all for ERC 20. So if someone sends you ERC 20 tokens, they are screwed. Just one point that you should always use ERC 223 when you create your own tokens. All right. Next one, when you write smart contract, well, when we develop for Web 2, you can use magic numbers here and there, just constant. Remember in Web 3 on EVM, contracts are immutable, which means once you deploy it, that's the code that lives on chain for forever. Now, how do you deal with that? Write settings, right? Whatever you see, like, hey, here's an algorithm, I'm calculating something, don't use magic numbers. You create a setting that you have getters and setters in your contract. Example. Let's say you want to have a point system on chain, and you use it to encourage users to get engaged, right? So very simple. Depending on the action, you give them points. Let's say it's D5. You give them 10 points when they deposit, 20 points when they place an order, and 0 point when they withdraw. Simple incentives, and maybe give them air jobs after some period when you release something. Now think about the algorithm I talk about. What's the problem? People can game it, right? They can deposit, withdraw, accumulate the tokens. So you want your contract to have a setter on the action and the point system for each action. So hey, maybe give them 10 points when they deposit, minus 10 points when they withdraw. There's still problems, but we're going to get to that. But at least make your smart contract settings mutable so you can control whatever you want to do in the future when things happen that you didn't predict, and you say, hey, I need to modify that. All right, I just said smart contracts are immutable. Very bad practice in reality, right? In Web 2, you can change your backend any moment, do a redeployment, no problem. In Web 3, you deploy your contract, that code lives on chain forever. What if you have additional business logic? What if, in the previous example, I'm going to get to that, people keep on gaming your point system? You need to be able to upgrade your smart contract. Well, fortunately, there's an established pattern to deal with that. Essentially, it's a proxy, right? You have your immutable contract, which lives on chain forever, But you have a proxy contract in front of that, which simply point to the immutable contract. And you can modify the address of the immutable, so you can make a new deployment and have the proxy contract point to the new deployment. This is how you make smart contracts upgradable. And example, back to the point system. Hey, what's the problem if you say you get 10 points when you deposit, minus 10 when you withdraw? Easy to gain, right? I can deposit like $1 every transaction, and then after 100 transactions, I withdraw $100, and I gain 90, well, whatever, 900, well, I cannot even count how many points you can gain by doing that. Also, if you are a DeFi protocol, just think about that. Let's say it's a pool. It's a, it's a pool on Uniswap. Let's pretend you are Uniswap, and you want to give people incentive to deposit into the pool. However, this incentive needs to adjust, because if you have enough liquidity in the pool, then there's no point to ask for more deposit into the pool. So you need a dynamic point system. I would say this is still very simplified. You want to check the pool's liquidity. And if it's a new pool, have very little liquidity, you want to give more points when people deposit into the pool. Or you want to give incentive based on the amount. Someone depositing $10 is obviously different from the next guy depositing $1,000. And then there's the action. So let's say you were on the previous formula and you want to upgrade to this one. In this case, you do need to upgrade your contract, and the proxy pattern enables you to do that. Super important here. There's a whole big issue with management when you upgrade contract, so you want to be careful about that. I'm not going to go into the details, but like I said, everything is battle tested. I know of company doing contract updates and mess up the state because they couldn't import the state from the previous contract, and then the whole contract is dead. So be careful about that and make sure you test. Yeah, we live in Web3. So what happens? Everything could be hacked, will be hacked. We all hope that when we write a smart contract, it's solid and nobody touch it, and you get audited. That's a good practice. But still, someday, if there's any problem in your code, any holes, it's gonna get hacked. Now, what happens when it gets hacked? Have a kill switch. Super, super important, because I know of DeFi protocol which didn't have kill switch, and it gets drained. So it gets hacked, and the hacks continues because they don't have upgradability and they don't have a kill switch. All they can do is sitting there watching their fund gets moved out of the contract, their funds and their customers' funds. Right? You look at some examples. On Solana, Pump.fund, they got hacked several months ago, and it was an ongoing process, but they did have a kill switch. So after a few hours, they killed it, upgraded the contract with fix, and they were able to restart. Web2 example, right? We all know Bybit got hacked just a few days ago, and Safe turned off their services to protect. That's a Web2 example. They can do that like this. Web3, you have to think about those kind of extreme conditions and make sure you protect yourself. Well, I'm going to use D5 as examples. At least okay, kill switch can have two different kind of forms. One is kill. You simply turn down the smart contract completely, so there's no way to turn it back on, right? And then you simply upgrade the contract to restart. Or you can pause it, which means you stop for that moment while you investigate and decide whether to upgrade the contract or simply, okay, it's not a big problem, you restart and pause it. So for DeFi, at least have those two. You may have more. You may pause trading, but at least stop deposit and stop withdrawal when something happens. Protect yourself and protect your customers. All right, this is tied to DAO. So when you have contracts with multiple settings and you can upgrade the contract, who is the owner? Think about that, right? Are you going to have a proxy contract that anyone can change the address to the master contract? Obviously, no. So in the proxy contract, you have to set an owner which says, hey, if the message sender is from this address, I let it through. Otherwise, no, reject. Now, think about this. We are in Web3. We are supposed to be trustless. If someone is reading your smart contract code and they see this address, what does it mean? This involves trust. Do I trust this address? Do I trust the person behind this address? Even if I trust this person, this developer, can I trust that he doesn't get hacked, right? What if his seed phrases get stolen and the hacker take over this address? So here's a question like fundamental to Web3, that are we going to put in something require trust into this whole process, into your smart contract? Now, unfortunately, when you have an upgradable contract, there will be an address, and this involves trust, and how can we make sure our customer trusts that? Here, I'm just going to give you a big warning. Never use personal wallet as the owner of your smart contract. Just no. Right. Oops. Yeah, don't use your wallet as the owner. The right process is decentralize it. Establish a DAO. Have the DAO control the smart contract. And anyone who questions, hey, what is this address? They can find the DAO. No, it's controlled by the stakeholders behind the DAO. You can set it up with ERC20 voting or NFT voting, or for a startup like early stage, you can use Multi-Sig and migrate to ERC20 when it gets bigger or when you go live. But don't use your wallet address. Set it up from the very beginning so customers can have confidence in you and have some level of trust. Right, so this ties back to the previous examples. Here's the very basic suggestion I would give to everyone. You have a ERC20 or ERC721 DAO to control the smart contract for regular settings. There is an exception. You need a separate owner for the kill switch, because guess what? When you do the proposal and vote, normally 7 days, maybe you do 3 days or 1 day. But for regular DAO governance, you do want to give the voters enough time to discuss and reflect and vote. So you don't want instant voting. So for the kill switch, what can you do? You can do a multi-sig sub-DAO or fallback console, which controls only this kill switch. And then when something happens, you have to do some offline work, call up the people who are the controller of the multi-sig and say, hey, I need 2 signatures to kill this flag, to kill the protocol or pause the protocol so we don't get drained. And in real life, it may be way more complicated than this. You may have different departments controlling different settings, different groups of settings in your smart contract. Totally reasonable, but at least do this. All right, so that's very simple presentation from the technical side, what you should do, just a general practice. We also have legal side discussion. That's totally different aspect. You know, developers, you want to get your business people to attend this, just QR code, scan it, and you see our schedule. Cool. I have a few minutes. Any questions? Cool. Yeah, I hope everyone gets something out of this. Like I said, everything I present here, I have real story of disasters because things are not handled correctly. I just hope that this will help people prevent. Go ahead. Sorry, Mike is coming.
Hello? Hello? Hey.
Yep.
Yeah, thank you so much for the presentation. I was wondering, you know, over the last few days, I've had a lot of conversations with people about the safe multi-sig, you know, downtime as a result, or the safe wallet downtime as a result of the Bybit exchange hack. And I was wondering how a DAO-governed protocol like you described with a multi-sig sub-DAO could, I guess, increase security in organizations like that.
Yeah. So one benefit, a good point, right? One benefit of having a proposal that having multi-sig to vote on it, there are safety rails, like periods before you get to the vote, voting period, and then time lock after. That's in general, like ERC20 or 721 or multi-sig. That gives you a chance to examine the transaction and make sure it is what you expected to see, right? Like Safe or Bybit, they are like doing blind signing on the hardware wallet. And the Safe UI shows something, supposedly, we actually don't know the details. Supposedly, Safe UI shows something. When you send to the hardware wallet, is something different that people signed blindly. When you have a proposal process, first is there's a period that you don't vote on it. You can examine the transaction and make sure it is what it is. And then you can say, okay, time to vote, multi-sig vote, or ERC20 or whatever, right? So in my example, only the kill switch is controlled by multi-sig, but bigger part is like upgradability. You upgrade your contract. That's so huge. You don't want to get misled and upgrade your contract to someone else's code and just get everything stolen. So before you vote, someone in the community or your core team should examine the transaction and make sure it's the right one. Then you vote, or you simply say, okay, no, don't touch it. And then after you vote, it's not executed right away. So there's a execution period that someone has to go there and click and say execute. So also there's additional safety during that period that someone can look at the transaction and make sure it's the right one. Additional safety that Bybit hacking could have been avoided. Very good point. Thank you. All right, 29 seconds. Thank you, guys. Have a good show.